Hello and welcome everyone. My name is Richard Garris. I'm a principal architect at Databricks. Databricks is the newest offering in the Azure stack. I'm going to talk a little bit today about how the developer data scientists can create new applications using Apache Spark and Azure Databricks. A little bit about myself. I'm a principal architect. I've been doing this for 14 plus years. My background is in advanced analytics. I've been working at Databricks for the last 3.5 years. I have degrees from Ohio State, go Bucks, as well as Carnegie Mellon. So a quick view of our agenda today. So I'm first going to talk about Azure Databricks, the newest offering on the Azure stack. Talk about an introduction to data science. And I'm going to go through the data science lifecycle. So really 3 key steps: ingesting your data, understanding and exploring your data, as well as doing modeling. I'm going to talk about how to integrate machine learning into your applications, as well as to give some example end-to-end use cases. So first, Azure Databricks. So we launched this product yesterday. This is a new offering from the Azure product team at Microsoft. This was a collaborative project. So Databricks is the original creators of the Apache Spark project. We created Databricks 2.5, 3 years ago. And yesterday we announced that both Microsoft and Databricks did a joint development project to launch Apache Spark in the cloud natively on Azure. So again, we'll go through a quick demonstration of this product toward the end of our presentation. But the key is that you'll have the instant access to Databricks Spark clusters, an interactive workspace to enable collaboration between different personas, both business analysts, data scientists, as well as data engineers, a native integration with the Azure services, including Power BI, SQL Data Warehouse, Blob Storage, Cosmos DB, as well as enterprise-grade Azure security, including integration with single sign-on, SLAs, as well as encryption. So a quick architecture diagram. So as you work within Azure, you have a number of different options in terms of creating your data sets. So you have IoT and streaming data, you have cloud storage, you have data warehousing, you have your Hadoop systems. But all those systems produce the data, but you need to actually get an analytics out of those. So the applications you're trying to achieve are on the right. So whether it's doing machine learning, BI, data exploration, it's hard to do given the plethora of data sources out there. So what we do within Databricks is the ability to take all of this data, create machine learning models as well as predictive intelligence, and then be able to deploy those in your applications. Okay, now into our production on data science. So as many of you know, AI is changing the world. So artificial intelligence is starting to become pervasive, everything from self-driving cars from companies like Waymo, Cortana, the digital assistant, as well as intelligent beating human beings at human games like AlphaGo or chess. So you see all these different types of AI applications. What is really the secret to AI? So AI isn't new. AI was introduced over 40 years ago with neural networks and other technologies, other algorithms. What has really changed to make this AI a reality here in 2017? So these are the companies behind those technologies. So Tesla is working on the self-driving car. You have Microsoft behind Cortana, as well as Google behind the AlphaGo and the Google Brain team. What do these companies have in common? All these companies have a large amount of data. So one of the key things about AI is really all about the data. So a NIPS paper was published in 2015 that really talked about how AI isn't really just about the algorithms, it's really about the big data. So in the green box right here in the middle of the screen is the actual machine learning code. So what Google is saying, as well as other people that wrote this paper, is that machine learning is a very small part of the overall infrastructure required to do advanced analytics, AI, and machine learning. The other pieces around it, the configuration, data collection, data verification, machine resource management, are all other pieces that are more critical and take more time to develop versus just the ML code. The other important part of this paper is that machine learning shouldn't be done as a single one pipeline. Having a platform to maintain these machine learning algorithms over time and maintain it in a way that's sustainable is also critical because the machine learning algorithms have to be adapted as your business changes. So I'm going to talk a little about data science platforms. So Gartner defines a data science platform as an end-to-end platform for developing and deploying models. So I'll go into more details of what it means to have a model in a minute. But another way to put this is that you have sophisticated statistical models, machine learning, neural networks, text analytics, and other advanced data mining techniques all within a single platform. We'll talk more about models in a minute, but I want to talk first about the business value of data science. So businesses have been doing data science for quite some time, different names, data mining, statistics, but really it's about adapting faster to change. So it's important to have data-driven decisions, and many of those decisions require doing things like advanced analytics. The way I like to summarize the business value of data science is really in a three-statement phrase. So presenting the right offer to the right customer at the right time. So it's really as simple as that, and that's really what data scientists do on a day-to-day basis in terms of how they drive the business. So let's talk a little about the data science lifecycle. So the data science lifecycle looks as follows. So this may look familiar to you for those in the software engineering space, very similar to Agile or Scrum. So the first thing you want to do is you set business goals. Then you want to understand your data sets. You want to create an hypothesis, and then you want to devise an experiment. So once you've done all those pieces, those are most of the critical pieces, really to understand what you're trying to accomplish from a business perspective. Then you can start to prepare your data, train, tune, and test that model, deploy that model, measure and evaluate the results, and rinse and repeat. The key here is that it's an agile process, and you're going to learn from your experiments each time you go through this cycle. So this is a graph that is published by a company called Crowdflower. Crowdflower is one of the leading companies that are advocates for data science here in the US. They're actually based in San Francisco. This report came out in 2016. And so what they found was 3 out of 5 data scientists spend 80% of their time collecting, cleaning, and organizing data. So this is another way of showing you that really the machine learning algorithms aren't really the key piece to developing AI. It's really that, really that big data, organizing all that data. So first part of the equation in terms of the actual life cycle is understanding your data sets. So you could have data structured in key value type storage, tabular like relational databases, graph, geocoded location data, time series data. Those are all different kinds of structured data sets. There's also unstructured data, things like text, sound and waveform data, sensor data, genomic data or scientific data. These are all different kinds of data that's required to create your models. So if you think about structured data, it's as simple as looking at a table, and here I'm looking at some log data, some text data, logs, tweets, social, as well as graph data. So in graph data, you're looking at like a social network in some cases, or it could be looking at drivers in terms of looking at moving from point A to point B. It could be airline data, many examples of graph. Geolocation data, time series data, which is usually done for stock charts or IoT applications. It's a good application for Spark streaming. Sound and waveform data. So these are things where you're actually collecting data from usually sensors or other types of sensors. In this case, the various sensors on a car for self-driving. Images and video, as well as genomic data. So the key is you want to first understand the data. You want to understand the descriptions and business meaning and value, the quality of your data. You want to explore and visualize it, as well as do things in terms of summary statistics to understand that data. So within Spark, one of the ways you can do data understanding is doing some simple traditional statistics, things like max, mean, standard deviation. If you need some more advanced statistics, you have skewness and kurtosis, or looking at relationships, looking at things like Pearson coefficients or Spearman correlations. You can also do visualizations. So on the left side, we're looking at a scatter plot. This is a good way to determine if your data has a linear correlation, as well as, or on the right side, which is more of a logistic correlation. So you can look at things visually as well as looking at things from a statistical perspective. So again, this is a slide previously. Again, a data science platform is really about deploying and developing models. And so now I'm going back to, what is a model? A model is a simplified, idealized representation of the real world. So what does that really mean? So for those of you that have a development background in software engineering, a class is an example of a model. So a class is a series of fields that represents the employee. But again, the class itself is not the employee. The employee is an actual human being that walks around and works in the real world. The class is just a representation of that person. So it could be viewed as a model. And likewise, if you're doing anything in architecture, you'll have a model of a building, or you may have a data model. For those of you that come from a DBA or a data background, you would recognize this as an ERD diagram showing you a data model for a relational database. In the data science world, you have different types of models. The most common one we think of is machine learning models. So those are learning a function. But there's other models as well, like statistical models, financial models, graph-based models, simulation models, predictive models, as well as biological models. In all these cases, these are all ways to represent the real world inside of a computer. So two broad categories of models for those of you that are relatively new to data science. One is called supervised learning, and the other one is called unsupervised learning. So in supervised learning, we're trying to learn a prediction based on either a label or a target. So if we're learning a label, let's say it's fraud or not fraud, or yes or no, then it's considered classification. If it's only a two-variable, or a binary classifier, then it's only two different things. Usually it's yes or no. If it's multi-class, then it can be multiple. So it could be a handful of categories. Regression, on the other hand, is predicting a target, so predicting an actual numeric value. Unsupervised learning is really considered discovery, so things like doing clustering, density estimation, dimensionality reduction, similarity search, frequent items. These are all used for different applications, so I won't go through all these in detail, but just as an example, frequent items is used often in market basket analysis, and clustering is used often to find anomaly detection. So again, anomaly detection, as I said, really is about trying to find uncommon observations. So it's used often in IoT applications as well as looking for fraud, looking for things outside of the norm. Lead scoring and recommendation tends to be more in the supervised category. So it's classifying a person as, will they become a buyer? Is this a good lead target or not? I'll provide a demo for that in a minute, as well as regression. For example, how much will this person spend? Or things like looking at similarity search, what products does this person of a similar user buy? I'll cover that also in a demonstration of how to do a recommendation engine. So it's very basic. A machine learning model is a mathematical function. So fx, if you guys recall, high school algebra. So the most simple mathematical model, or simple machine learning model, is really linear regression. So it's y equals mx plus b. That's the basic equation for it. So what you're trying to do is, given a data set of n size, you're trying to predict or trying to learn a function that follows this pattern. So you're going to estimate the coefficients and the intercept given your data set and learn all of that based on the data. So that's one example of a model. Another model, which is a nonlinear model, is a decision tree. You can think of a decision tree like a flowchart. It's an if-then-else statement that is actually learning those if-then-else rules based on your data set. So as an example of this, if you have a vehicle, let's say it's a Toyota Prius, you're trying to figure out, is the Toyota Prius going to be high mileage or low mileage? So here you can learn those rules. An example rule is if the car is heavy, then typically it's going to have low gas mileage. If it's not heavy, but it has low horsepower, it could also be high mileage. But if it's low horsepower, probably it's going to be low mileage. So it gives you a sense of how you can create a decision tree given some data. So here is the actual listing of the actual methods in MLlib. We also support using other libraries, such as open source R, as well as other Python libraries. But these comes in MLlib, and these are distributed libraries that are built into Spark. So things like Gaussian mixture models, k-means, LDA, PIC, as well as ALS for doing recommendations. Those are kind of the most popular algorithms, as well as supervised methods. So things like logistic regression, naive Bayes, linear SVMs, decision trees, random forests, gradient boosted decision trees. Those are the most common methods in MLlib, or most commonly used. So I mentioned a model as a mathematical function, but what is a model really in the real world? Really, it's a complex set of components, which we call a pipeline. So it's not just about that one method that's being learned from my data set, but all of the other pieces that create that machine learning model. You recall that first image that shows the ML code being a very small part. These are all the other pieces that kind of surround that model. So if you take a basic data science or machine learning course, they give you this kind of diagram. You say load data, extract features, train the model, and then you evaluate. So this is a very simple pipeline. These are the pipelines I really see in the real world. So you have a number of different data sources. You have a number of different ways to extract your features. You do transformation 1, 2, and 3. You train one model, you train another model, you ensemble those, you evaluate it. So they end up being very, very complex. And so one of the key pieces of this is that if you're doing all this work to learn this, this model, then you have to figure out how do I productionize these, which is always very challenging. So in my next section, I'm going to talk about how do you integrate machine learning into your actual production applications. So data science today mainly involves what I call prototyping. So most data scientists work in Python or R, and those environments aren't typically used in production. Mostly they're used for data science or doing experimentation. And so in order to actually take your models and move this into production, you have to actually re-implement the model, typically in Java. It could be in C or C++. But this is not ideal because it takes extra work, requires different code paths. Data science doesn't often translate to production. It's also slow to update the models, right? So one of the things that was introduced in MLlib and in MLlib Apache Spark 2.x was model serialization. So what it allows you to do is continue to use your favorite language, Python or R, to actually train your model, but then actually productionize it. You can actually save that model to a file and then reload it in Java. Because Apache Spark supports Java, Scala, Python, R, and SQL, you can actually mix and match those languages and still use the same underlying engine, including MLlib. So a couple of code snippets for developers, just to give you a sense of how this would work. So you would call fit to actually train your model on your pipeline. You get a pipeline object back from this. So this is your actual model. And you simply say write.save, give it a path. It'll save that model to the file system. So once you save your model, I'm going to go into a little bit of introspection of what's actually saved. So the first thing you'll see is you'll have metadata, which is information about the training activity, as well as stages of your pipeline. So one of the key steps in terms of machine learning is to actually take all your data and turn it into numeric values. Machine learning can't learn off of string values. It can learn off of actual numeric values, integers. So in this case, we're taking a set of strings and simply translating it into an array of values. So in this case, we're taking some data. We have private, self-employed, local government, taking those strings and representing those as integers. You can think of it almost like a hash map. So in some ways, the first step in this is really the first model you're getting is a simple hash map. It's actually taking one of these strings and giving back an integer value. A slightly more complex stage in the machine learning is actually learning the actual function itself. In this case, we're using logistic regression. It's similar to linear regression, but for binary classification. And so in this case, we actually learn, given our data set, what are the coefficients and the intercept. So you can see here that if you look at the model itself, that's here in the white square in the right corner, those list the coefficients as well as the intercept for my data set. This is a different model. So in some cases, you may want to try a different model like decision trees. In the case of decision trees, you're not trying to learn a function of coefficients. Instead, you're learning splits. So you're learning the actual tree structure given my data set. So it's actually trying to predict the actual if, then, else conditionals to actually do your predictions. So you can see here that this is shown in a tree format, or excuse me, a table format. On the next slide, I'm going to show it in a tree format, which is more intuitive. What it's saying here is that given the data, I estimate that I'm going to split on feature 23. If it's equal to 0, then I go to the left. And if it's less than 0, I go to the right. And likewise, I just sit down the tree, and then I get a 1 or 0 prediction on the leaves. So this is a built-in visualization in Databricks, but it gives you a way to look at your model and see what is being learned given your data set. All right, so Databricks. So Databricks plus the ML pipelines available in Apache Spark are really the ideal tool for doing data science. So if you think about data science, it's a highly iterative activity. You have lots of data sources, lots of dirty data, lots and lots of data to join to. So it gives you an end-to-end platform for be able to experiment, be able to come up with new ways of analyzing your data sets, as well as productionizing your models. So talk a little about Databricks Runtime. So this is part of the Azure Databricks offering. So Databricks Runtime is a commercial version of Apache Spark. It's built on two different components. One is called Databricks I/O. The other one is called Databricks Serverless. So Databricks I/O is a faster layer to actually access common data sources in Azure Blob Storage, including formats like Parquet, JSON, CSV. And it gives even up to 5x more performance than using vanilla open source Apache Spark. On the right side is Databricks Serverless. So it's a fully managed cloud service with tuned clusters, tuned by the company behind Apache Spark, as well as reliable sharing and resource isolation. So you can have a single cluster or a resource pool and have a number of data scientists as well as data engineers all using the same resources in the Azure virtual machines. So one key note about the premise behind Databricks as well as Apache Spark is really about cost optimization through linear scaling. So linear scaling means that you can actually take a large data set, let's say it's a terabyte, let's say you run your model, this takes 2 hours to train that model with 10 nodes. In theory, you can double the number of nodes to 20, and it should reduce the runtime in half, so from 2 hours to 1 hour. Obviously, there's network overhead and some other variables, but the idea is that you can actually scale up and scale down your number of resources depending on your load. So the other piece to Databricks, or Azure Databricks, is the collaborative workspace. So this is a collaborative workspace that allows different personas, data scientists, data engineers, as well as business analysts, to all work in the same environment. So you can create production jobs as a data engineer, interactive notebooks as a data scientist, and then publish results using interactive dashboards. I'll cover some of this in our demonstration. You could also use the language of your choice, SQL, R, Scala, or Python. You could also load your own custom libraries, or you can use the built-in libraries, including Graph, ML, or your deep learning libraries like TensorFlow. So wrapping it all up, I'm going to go ahead and build out this slide. So really, for the Databricks Collaborative Workspace, it gives you the ability to cross-functional collaboration across your multiple business units. It streamlines your analytical workflows. And the Databricks runtime unifies all the personas under Apache Spark and gives increased performance and reduced TCO. And all of this is wrapped around our enterprise security, SOC 2, as well as ISO compliance, as well as open APIs to connect to. Okay. So if you'd like some more information about Databricks and Azure, go to databricks.com/Azure. I'll show you a view of this page in the presentation, and it'll give you a lot more information about how to join that. Now I'm going to go through a couple of example applications to show you guys how to, guys and gals, to show you how to use Databricks. Okay, so I'm logged into Azure Databricks. So you can see here that it's a simple Azure Databricks portal. There's a single web page around how I can access my data. One thing to note is this is a managed service offering. So that means to you is that we actually update and add new versions of Spark on your behalf. So at any point in time, if you need new functionality, need new algorithms, as we publish those, they'll be published in the environment. There's no more long upgrades or other cycles to get the latest version of Apache Spark. To create a cluster is very simple. You can either take an existing cluster that you've already spun up before and restart it. You can clone a cluster to actually reuse the existing configuration, or create a new cluster. It's really meant to be self-service. So you can simply say, I want a cluster, give the cluster a name, select the version of Databricks you want to use, specify the worker types, the virtual machines that you want to use for your nodes, specify the inactivity timeout, and click Create. Really simple. I've already spun up a cluster, the Microsoft Connect cluster that I'm going to use today for the demonstration. We can go through that in detail. Okay, so I'm going to give an example of a lead scoring application. So everyone out there, if you're in a B2C type business, has to understand how to score their leads in order to actually find net new customers, acquire new customers. So the problem is you may get a lot of leads. Here at Databricks, we get a lot of leads coming into our website. And so we really want to find the best possible leads to then target as customers of Databricks. So one of the ways that we target customers is looking for customers that have enough IT budget to afford Databricks. So in my case, I'm going to use an example problem looking for companies that have more than $100 million in IT budget. But that's just an example. You don't need $100 million to buy Databricks. So I'm using what's called here Markdown. Markdown is a way to document your code in the same place as you're actually writing it. And I'm using what we call Databricks notebooks. So if you've used or heard of IPython notebooks or Zeppelin, very similar. We built these notebooks in-house to really integrate a notebook with Spark natively. So you can do things like run your data at scale, even little things like being able to cancel and restart your jobs, all within one environment, as well as collaborate. So here I'm logged into the notebook, and I see that I'm also logged in from my other browser tab here. So I can do things like collaborate, much like Docs. Okay, so given my business problem, the first thing I need to do is ingest the data set. So the first thing I'm going to show you is how to ingest data from, in this case, JDBC. So here I'm actually connecting out to a JDBC source. I'm connecting to a MySQL table. I'm loading that data, and then I'm going to be able to display that. So one of the key differentiators between a Databricks and a Spark versus things like SQL Server or other databases you may be used to is these are all reference sources. So in this case, this data set I'm loading called loans, which I'm going to show in a minute, is a number of columns, and it's actually a CSV file sitting out on Azure Blob Storage. So it's actually a reference to that source. It's not the actual data loaded like you would with SQL Server. Okay. All right. Scrolling down here. Okay. So as an example of this, let's say I have a series of IT budgets. Here's where I'm actually doing a quick cat of that file. But I don't have all the IT budgets. IT budgets are obviously confidential, so not all the companies will publish those. So what I'm going to do is I'm going to try to learn a function, learn a model that's going to predict the IT budget given some public data. So the first thing I'm going to do is use some featureization. Here I'm taking those IT budgets and translating into a table. I use what we call RDDs to actually do that translation. This is what's being done here. And here are the various company IDs and the actual budgets itself. Here's where I'm actually going to join my IT budget table with actual companies, public data, to come up with an overall data set for learning my model. So here I have actual lists of real company names, so Nordstrom here in the Pacific Northwest, as well as other companies around the area, Facebook down near me, near Palo Alto, as well as other organizations. So these are all public pieces of information, so things like the sector the company is in, the number of employees, their revenue, as well as their IT budget if it's available. I can also join sources from a system called Hive. For those of you that have been working in big data for things like HDI, you're used to Hive as a data source. You can also join those sources natively in Databricks. In this case, I'm going to join with a table called zip code metro map. Actually map these various companies to actual locations given a metro area. So within Databricks, we also have point-and-click ways to do visualization. And so in this case, I'm looking at the metro map. So here I have a table of data. If I want to quickly do a map, I can take a look at where my companies are located based on this map of the United States. So I see here that many companies are here in California. Some are here in Washington. Some are in New York. You can see all these different companies and where they're located around the US. Okay, so those are some brief ways of kind of doing the data ingestion side. So then we go into our exploration phase. So in our exploration phase, here's where we're going to do some basic statistics. So I take my columns like employees, revenue, and budget. I can see here that the mean number of employees is about 200,000. So these are very large companies. The mean amount of revenue is about 9 billion. In the IT budget, the average is about 340 million. So it gives you some idea of like the data. I also like to use histograms. So it gives you a sense of distribution of your data set. So I can see here that the vast majority of companies have relatively small budgets, under 20 million. But as you get into other companies, you see fewer numbers as you get into the higher IT budgets. Likewise, you can split it out by sector using a pie chart, as well as looking at that same chart, the same graph, but instead looking at the number of companies, looking at it by the amount of IT budget in various areas. So you can see New York and California dominate. I also like to use scatter plots. So in this case, I'm looking at a scatter plot of the revenue versus the budget. I'm trying to validate my assumption that as you add more revenue, you have more IT budget. And I see that's pretty much true. So as you have more revenue, you spend more on IT. But as you get into the upper echelons of revenue, you tend to have a less predictable track in terms of revenue. Here, it's much more predictable. Okay, So here's where I'm going to create my features. One of the nice things about Databricks is the ability to combine SQL with, in this case, Python. So here I have a SQL statement. I wrap it in a string. I say run this SQL and make this my feature selection. And here I can actually see my features. So I hear the name of the company, sector, industries, number of employees, et cetera. And here's where I'm going to try to predict the IT budget. I do a quick translation from the actual dollar value of the IT budget to a 1 or a 0. This is a very popular way to simplify machine learning, is instead of actually trying to predict the exact IT budget, which would be hard, here I'm just going to predict if it's over a certain amount, over 100 million. Okay. Here's where I'm actually going to do my machine learning. So I'm doing a couple of different techniques here, so bear with me. So here I'm actually taking the sectors and the industries and breaking those into tokens. And then I'm going to take these 4 columns and turn them into my features to actually learn my model. So I'll show you what this looks like in a minute. As a best practice, I'm actually going to save my model after I train it. This is a very quick model because I'm using a large number of nodes, and it runs very quickly. But if you're training a big model, best practice is to save it after you've trained it. And these are my actual features. So in this case, I've broken out my sector into tokens. So I see here this is the one token is technology. In this case, this particular company is in computer software and hosting. This is my vector, and these are the features I'm using. So a feature is actually an array. So here's the actual numeric values I'm using to train my model. Okay. So this is where I actually do my model training itself. So here I'm actually training a simple logistic regression. It's a binary classifier. I train my model using what's called a train tune validation split. So I'm doing a split my data set between a training set and a test set, so I know that I have the best model. I go ahead and call fit. Again, I call write just to save that best model. And then I can take a look at the actual coefficients, what was actually learned from the data set. So these are actual coefficients itself, as well as the intercept. Intercept is 0, here's the coefficients. So this is the actual model learned from the data set. So I can see here the model is okay. 0.78 is not a bad model, so 78%. You can think of it like accuracy. It's actually a measure called AUC, or area under the curve. You can actually get a view of this here. This is actually showing you the area under the curve and the various thresholds. You can think of it like a trade-off between the false positive and true positive rate in terms of the quality of that model. I'm also going to train a decision tree. That's the other model I'm going to train in this case. I do exactly the same. So one of the beauties of using the MLlib pipeline technique is I only change one thing. I change the from a LR to a DT in the variables. I call fit again, and I'm good to go. So I can easily experiment with different machine learning algorithms within my pipelines. So again, I save a model as a best practice. And now I have a much better model. So I have a 0.98 is my best model. So that's a much more accurate model. So it seems to be working really well. I can look at all my splits of my decision tree in detail here, or as I was showing in the slides, I can actually look at it based on a visualization like this, showing the various tree. I like to actually look at things a little bit differently, so I like this view for a quick view, but I like to look at in text. So this is my if then else statement. So for those of you that do programming, this looks very familiar. So in summary, what this model has learned is that if companies have a lot of revenue, over $2 billion, they tend to spend more than $100 million in IT. But if you're in computer software or financial services, you tend to spend more on IT than others. On the contrary, if you're in state and local government, in retail, industrials, then you tend to spend less on IT than typical. So those are actually is pretty intuitive. So this, based on my experience working with various companies, it is true that state and local government don't spend as much on IT as you would think. Okay, so then once you have your model, 3 different ways within Databricks to deploy it. The first way is to do it through a dashboard. So I'm going to jump into what we call our dashboard views. So right now I'm looking at what we call our code view. I can change this to doing just results only. But one of the ways that you can publish this to, like say, your actual sales team is through what we call our dashboards. So here's my dashboard. I can click present. So here might be my total inbound leads. Let's say 288 are qualified, or 35%. This may be from like the day before. I can do a top 10 list. Here's my top 10 leads by revenue with Walmart on the top. I can see top leads by different sectors. as well as leads by state. And you can also do things, let's say you have your sales force and they're very geographically distributed. You can also have in this case, a widget to actually change from looking at California as my state or looking at Illinois. So this gives you the ability to have a dashboard which you can then give to your sales team so that every day they can come in and check their leads and see how many leads they have and who they need to follow up with. Okay, let's go back to the code view. So that's one way to productionize your model. Another way to do it is through what we call streaming. I'm going to jump down here. So one of the amazing parts of Apache Spark is the ability to combine multiple engines. So you can do things like machine learning, but you can also do things like streaming. So in this case, I'm going to jump down here. These are the various components of my dashboard I showed a minute ago. And this is what I'm going to show you in terms of streaming. So again, I take my data set, I'm loading it into a stream. This is exactly the same code that I did in batch. The only thing I've changed is one line. Instead of doing read, I do read stream. And then here's where I can actually turn that into something where I can do predictions. So here I'm where I'm going to take in let's say my leads as they come in, as they visit my web page. I pass it through, in this case, a machine learning function. This is the model I'm using up here, right over here. And this is where I'm going to do my predictions. So one of the nice things in our notebooks is also the ability to do streaming predictions. So in this case, I'm going to initialize my stream, kicking that off. So again, it's kicking off various jobs within Databricks to run this. I can actually see that right in the notebook in the debugger view. I can see here that this is the actual execution plan of that. So again, it's reading it from this table, and as data is coming in, as there's more activity, it's actually loading that into my context and calling predict on that function. So in this case, you can see here that leads are actually coming onto the page. I can see here with the blue being that they're predicted to be a good lead, as well as the orange is the not so good leads. And as time occurs, I can see the leads and how they measure up as they come in. I can also change the view slightly. Maybe I don't want to see the prediction. Maybe I want to see things by sector. That might be more interesting. So I can see here what are the various sectors as they come in. But it gives you a real-time dashboard of the behavior of customers as they enter the system and site. Okay. Jumping ahead here. If I go to my next demonstration, the other one is recommendations. So recommendation engines are very popular. Netflix made it famous through the Netflix Prize a number of years ago. But Netflix, as well as various online shopping centers, have made recommendations kind of a key part of any website or any e-commerce activity. So here I'm looking at various items that people have bought, as well as the rating they gave those various items. So I see here one of my favorite movies, Donnie Darko, Swiss Army knife, various other items that people have bought. This is in a table what I call reviews. So within this, I can actually do some basic data cleanup. So in this case, I'm going to drop any items that don't have the right data, as well as get the list of items. So I'm going to look at one item here. This is called a classic accessory, so a veranda patio studio. Then I'm going to register these as temporary tables. So one of the things you can do within a notebook is register temporary tables. So if you don't want to actually save a permanent table and give it access to other people in your company, you can also save it temporarily. And then do things like join your data sets with these temporary tables. So in this case, I'm taking this table called items and brands. I'm using %SQL, which is a magic cell, to join those data sources together. And here's where I can actually see my list of brands and items and what's being sold. So I can do some basic exploration. In this case, I'm looking at the number of items sold per brand. So I can see here that this is a simple table view. Maybe it's easier to see in a bar chart. There we go. So I can see here that unknown and generic are the top two. Disney, Mattel, and Dorman, as well as AC Delco are the next four. So these are very popular brands on this particular e-commerce site. All right. So I also want to kind of get a sense of what are some of the keywords in the review text of these different brands. So you can see here these are those keywords. I can also look for what are some of the keywords based on the actual brand itself. So I can see here that people that are buying Apple tend to buy iPhones or various cases for those iPhones. It could be an iPad, etc. All right. So I'm going to talk about using Azure Databricks to serve machine learning models. So in this case, we're looking at the reviews on Amazon.com of various books. And I'm just going to show you how you can build an application like this on your actual web page. So again, this is my review text that I showed before. And this is an explanation of how to actually do the sparse. How this actually works in practice in terms of building what we call a collaborative filter. So the way the recommendation engine works, it looks for people that are like you. It recommends things that other people like you have also liked. Kind of the easy way to say that. In terms of the math, and I won't go through all this in detail, it's what we call matrix factorization. So this is looking at the list of users, list of items, doing matrix factorization to come up with here is the other things that you may have not bought before, but you should buy because other people like you have actually bought it. So in other words, it's a way to take something like Office Space and recommend a red stapler. Okay. So given my data set, here is a list of the various items. I'm looking at one particular user. This has been anonymized, so A30X. These are items that this person bought: Kit Kat bars. Let's see here, an Oscillo, a new line entertainment, a set of earbuds from Sony, etc. So here's where I'm actually going to train my model using an algorithm called ALS, alternating least squares. This is, again, a collaborative filtering algorithm, a very common algorithm for doing recommendations. I do a couple of different things on here. One is to generate a hash code, meaning generate a unique ID for each user, as well as a unique ID for each item. Okay. So I train my recommendation engine using one line of code. So I say model and transform it. And then given that same user, A30X, here are the things we recommend for that individual. So things like, looks like a Star Trek attack wing, a little thinker toy, a Star Trek item, etc. Okay. So a common way now that I actually have various predictions for various users is how do I actually turn this into something I can use in production? So within Databricks, we have what we call one-step scheduling. So what it gives you the ability to do is take any notebook and put it on a fixed schedule. So in this case, I'm actually going to do my prediction. Let's say I'm going to do it every night. I'm going to say here, under the schedule, I want to set at midnight. Let's just say Eastern time. Okay. In this case, I'm going to kick off an actual cluster each time I want this to run. This is really powerful in terms of cost savings because you can kick off a set of virtual machines. You can train the model and have predictions for each of your users stored off to, let's say, a NoSQL database or maybe a SQL Server database, and then automatically turns those machines off. So what it allows you to do is do things like complicated computation. ALS is a relatively complicated algorithm using the power of distributed compute, and only pay for those machines for when you need to use them. And then after it finishes, it automatically returns those machines back to Microsoft Azure. Okay. All right, so I'm going to jump back and I'm going to show you guys a couple of different things just for follow-up. So I'll publish both of these notebooks in a place where you can pick them up and use them in your own Microsoft Azure Databricks environments. Azure Databricks is now available in private preview. So you go to our webpage, databricks.com/Azure. You can go onto this page and sign up for our private preview. And then you can add Databricks to your environment. If you go through our approval process, it's very light. And then you'll be able to evaluate and try out Databricks for your own data science projects in your companies. Okay. All right, thank you. Thanks, everyone, and have a great rest of your day.